Alright, so we want to find the other 5 trig functions, values of the other 5 trig functions given a single value. And we looked at earlier how to do this with identities, but it does get kind of crazy. So we can just use a single triangle to do this. So I'm given cotangent of x is equal to -1/3, and x is in quadrant 2. Right, so this will help me to know if my values for the other 5 will be positive or negative. So I want to start off just by making a right triangle. There's my right triangle. And I have 2 other angles. It does not matter what angle I choose to work from. I'm always partial to the bottom right for some reason. Doesn't matter. But I'm going to choose that angle to be x. And we're going off of SOHCAHTOA. SOHCAHTOA. Alright, SOHCAHTOA. But I'm given cotangent. Cotangent, remember, relates to the trig function tangent. Tangent is, tangent of x is equal to the opposite over the adjacent. So cotangent is the reciprocal of that. It's adjacent over opposite. And I'm going to use that to fill in my triangle. Cotangent is adjacent over opposite, and I'm given that cotangent is, I'm going to forget about the sign for a second, 1/3. So that means from x, the adjacent side length, so the one next to it, is 1. And the opposite, the one across from it, will be 3. And so I'll use Pythagorean theorem to find, in this case, my hypotenuse. Remember, Pythagorean theorem is a squared plus b squared equals c squared. C is always my hypotenuse. C is always my hypotenuse. In this case, that's what I am looking for. It does not matter which side you choose to be A, which side you choose to be B. It'll come out the same. So 3 squared plus 1 squared equals c squared. 9 plus 1 equals c squared. 10 equals c squared. Take the square root of both sides. I get c equals the square root of 10. Now, c equals, the square root of 10 is as simple as it gets. So we'll move on. This is the square root of 10. All right. Once I have my triangle solved, the rest of it is just listing out what the other trig functions are. I know in a triangle, sine is opposite over hypotenuse. So I'm going to go, here's x. Opposite is 3. And my hypotenuse is the square root of 10. We want to rationalize our answer, meaning I don't want the square root in the bottom, so I'm going to multiply the top and the bottom times the square root of 10. So I get 3 square roots of 10 over 10. Now we're in quadrant 2. You can't see that. Quadrant 2. So is sine going to be positive or negative? It's positive, right? Quadrant 2 is over here. We are definitely above the y-axis, the x-axis. Sine being y is positive. So there's sine of x. Cosine of x, according to SOHCAHTOA, is the adjacent over the hypotenuse. So, again, going back to x, adjacent is 1. My hypotenuse is the square root of 10. Again, I want to rationalize that, so I'll multiply the top and bottom times the square root of 10, and I get the square root of 10 over 10. We are in quadrant 2. Will cosine be positive or negative? Cosine is negative. Alright, so I have cotangent, sine, cosine. Tangent should be an easy one to find. Tangent is just the reciprocal of cotangent. So if cotangent is, we're originally given it's -1/3, flip that over, and tangent is -3. Right? Just the reciprocal of cotangent. So I have 4 out of the 6. The last 2 trig functions, I have cosecant of x. And remember, cosecant is just the reciprocal of sine. So I'm going to start with, before I rationalized it, 3 over the square root of 10. And I'm going to flip that over, square root of 10 over 3. We said sine was positive, so cosecant will be positive. And then the last one, secant, remember, is the reciprocal of cosine. So again, starting with the value I had before I rationalized it, 1 over the square root of 10. Secant is the reciprocal, so I'll just flip it over and get the square root of 10 over 1, which is just the square root of 10. We said cosine was negative, so secant is negative. Our original problem asked us to find the value of the other 5 trig functions, and we found sine, cosine, tangent, cosecant, and secant, all values for the other 5 trig functions.